So let's take a look at some transformations of the tangent function. If we have any function, we can transform it into another function by translating it, left or right, up or down. We can stretch it, we can shrink it, we can stretch or compress it either vertically or horizontally. So let's take a look at some of those transformations of the tangent function. All right, so this first, wow, that's interesting. This is supposed to be A. A, looks like A, B, C, D. Okay. So in part A, we've got 2 times the tangent function. Basically, it's going to take the output of the tangent function and scale it by a factor of 2. Multiply every y coordinate of tangent, the output of the tangent, by 2. So we consider this a vertical stretch. A vertical stretch, right? Stretching it in the y direction. Stretch by a factor of 2. A factor of 2, right? We're just multiplying everything by 2. Now, what's that going to do to our function? Now, it's not going to change the asymptotes, right? We're stretching it vertically, not horizontally, so those asymptotes are going to stay the same. So we're still going to have asymptotes at plus and minus pi over 2. We're going to have asymptotes at plus and minus 3 pi over 2, right? And then, right, so it's not stretching it horizontally at all, only vertically. So really, and all those 0 points, the zeros are always right in the middle between the asymptotes, right? So all of those are going to stay the same as well, right? Because you're just scaling 0 by a factor of 2. So the key feature that you're going to, that's going to be stretched, that you're going to notice, is that, at 45 degrees, here's 45 degrees, pi over 4, right, is right here. That's 45 degrees. Now normally it's 1, but now it's going to be 2. And the point that's normally here at negative pi over 4, which is negative 45 degrees, which is normally at 1, is going to be at negative 2. All right, so this is negative 2, and this is positive 2. All right, and then we're still going to have the same asymptotes. So the function will just be stretched, right? And the thing that will be noticeable will be those points at 45 degrees or that have a reference angle essentially of 45 degrees. Okay, and then the pattern is just going to repeat. So I'm going to have 2 and negative 2 here, and then I'm just going to sketch in my graph, right? And it's going to come here. It's going to go negative 2. Oops, actually, that's a little off. So it's going to look something like that. All right, so it's just going to repeat. That pattern just repeats. So I'll just sketch that in. All right, so something like that. Okay, and then finally over here, it's going to pass through here at 2 and like that. Oops. All right, so you get the idea there. All right, so that one's stretched vertically by a factor of 2. Now this one, part B here, is we're just taking all the outputs of tangent and subtracting 2. So this is a vertical translation down by 2 units. So vertical translation. And it's going down because we're subtracting 2, down by 2 units. Okay, so we're just going to take the tangent function that we had before, and just shift everything down by 2 units. So what was going through 0 now goes through negative 2. But it's not going to change the asymptotes at all. So I'm just going to sketch in those asymptotes again, the same asymptotes, right? Because we're just translating everything down, and that's not going to do anything to the asymptotes. So I'll sketch those in. Whoops, that's kind of off there. Let's see. All right, there's my asymptotes. Now, normally it would go through 0, 0, but because I'm taking that and subtracting 2 from it, now it's going to go through this point here at 0, negative 2. And then it's going to go up and down by 1, right? We're going to get tangent. At 45 degrees, it's going to be 1, but then it's 1 minus 2, so it becomes negative 1. And at negative 45 degrees, or pi over 4, is going to be negative 1, right? But minus 2, so we're at negative 3 here. Okay, so everything is just shifted down by by 2 units, right? So it's going to have the same shape. It's just going to, that little inflection is going to go through a different point, okay? And then it's just going to repeat, right? I'm going to have that same pattern, and it's just going to repeat every pi radians, okay? So it's going to look like this and this, right? And so it's going to go like that. And we'll do one more cycle over here. So it's going to go through 2 and then up and down by 1. And then we have another cycle that looks like that. Okay, we can also draw this one. So it would look like that and like that. Okay, so that's the tangent function translated down by 2 units. Okay. Now let's take a look at these next 2. In these cases, we've got some vertical transformations going on. So just like when we looked at the sine and cosine function, you're basically taking the input, right? The input to the tangent, instead of being theta, is now 2 theta, right? So we're basically taking theta, turning up the volume by a factor of 2, okay? So it's going to take half as much theta to get the same amount of tangent. Okay, so that's kind of the way I think about it. So what it does is it compresses it horizontally. It's going to compress the function horizontally. So this is a horizontal compression by a factor of 1/2, right? We're multiplying those theta values by a half. So that is going to change where the asymptotes are, right? So the asymptotes, rather than happening at pi over 2 and minus pi over 2, now when I put in pi over 4 and multiply by 2, I get pi over 2, and I know where those asymptotes occur at pi over 2. So it takes an input of pi over 4, right, to this 2 theta in order to get an output of pi over 2, which is the input to the tangent. So again, I kind of think of it as, these cascading functions where you've got their tangent function, and then your input is 2 theta. You're taking theta and multiplying by 2. All right, so when theta is pi over 4, we're going to get an asymptote, okay, and negative pi over 4. Right, so everything's just going to happen quicker, right? Theta, we're turning up the volume on theta, and so it doesn't take as much theta to go through cycles, right? Oops. Okay, so here are all my asymptotes, a lot closer together, right? So, okay, so I've got all the asymptotes. We're going to have asymptotes at pi over 4 and minus pi over 4. We're going to have one here at 3 pi over 4 and minus 3 pi over 4. So you can see they're essentially odd multiples of pi over 4 now rather than pi over 2. So we have 5 pi over 4 and minus 5 pi over 4. And this is going to be 7 pi over 4 and minus 7 pi over 4. Okay, so that's where my asymptotes are. And the period is half of what it was before, right? Because the period was pi before, now the period is pi over 2. And we can draw in our function. So it's still going to be 0 at 0, but halfway between that 0 point and the asymptotes, we're going to be at 1 and minus 1. Okay, so one cycle looks like this. Okay, looks something like that. And then it's just going to repeat, right? It's going to pass through 0, and then it's going to go plus and minus 1 on either side, halfway between the 0 point and the asymptotes. And then we have another cycle. All right, so I drew in all those cycles. It takes a little while, so so I went ahead and did it off camera here. So all right, so that's a horizontal compression. Now let's take a look at what happens when we have the tangent of theta minus 2. Now notice that these parentheses are very important. If you don't put parentheses around it, it looks just like what we had in part B up here, right? So the parentheses make a big difference. That in part B, we had a vertical translation down by 2, right? Because we're taking the tangent of theta and subtracting 2 from that. In part D, we're actually taking theta, subtracting 2, and then feeding it into the tangent function. Okay, so what's going to happen there? It's going to take 2 more units of theta in order to get the same output, right? So now you have to increase theta by 2 in order to get the same output, which means that the graph is going to be translated horizontally right by 2 units. Okay, so this is a horizontal translation to the right by 2 units. Okay. Now this is a little tricky because you notice my axis is all in terms of pi. So it's like adding 2 to it, and you have to kind of like think about, okay, pi is 3.14, and like, okay, what is that? So I did some calculations to figure out where these were. So that it means that those asymptotes get translated over by 2 units. So they end up looking like this. All right, I had to do some calculations to figure out where they would be with respect to the axis I have here. So I've got another one here, right? So, but basically I just took, they were normally at negative pi over 2 and positive pi over 2. If I add 2, I just did a calculation to see where they'd be in terms of pi. Okay, so anyway, let's take, I've got another one over here. And I think that's it, right? Okay, so, but again, I'm going to have the 0 is going to be halfway in between these asymptotes. So I'm going to have a 0 about here, and then halfway in between those 0 points and the asymptotes, it's going to be plus and minus 1. Okay, so I'm going to have a plus and minus 1 about here and here, but halfway in between. Okay, and then I can just kind of draw in the shape. All right, so there's one cycle. All right, so essentially everything's getting moved to the right. So this particular asymptote was the negative pi over 2 asymptote, but then I had to shift it by 2 units. So now this asymptote is at 2 minus pi over 2. This asymptote is at 2 plus pi over 2, right? This one here is 2 minus 3 pi over 2, and this one's at 2 minus 5 pi over 2. Now you can see that the asymptote that was at 3 pi over 2 got shifted out of the picture, right? It's off beyond pi over 2. Okay, because when I add 2 to it, it becomes greater than pi over 2. So I'm just going to have this pattern that repeats. So I'm just going to sketch this in, and then, so I always know that halfway between the asymptotes I have a 0, and then halfway between that 0 and the asymptotes I have a 1 and a minus 1. Right, kind of estimating where the halfway point is. Okay, so there we go. That's what it looks like. Again, it's going to repeat. I'm just going to plot those points that are kind of the key features, and then sketch in generally what it looks like. Okay, so over here I'm going to have a little bit of something that's going to go off to infinity over here. Now halfway in between, let's see, I'm going over, it's going to be about here and here, and so this other one's going to go off here, but I've got my other asymptote is over here. It's beyond pi over 2, so it's going to go something like that. All right, so there is a horizontal translation to the right by 2 units. Now these last two are reflections. Okay, when we take the negative of a function, we get a reflection across the x-axis, or in this case, I guess it is the x-axis, isn't it? We had this labeled as the x-axis. I guess I've got my function in terms of theta, but I've got my axis says x. But so I guess this really would be the theta axis, since my function's in terms of theta. So this is a reflection across the theta axis. In this case, because my my variable is theta. Okay, so what happens there? So all the positive values become negative, the negative values become positive. It's not going to change the asymptotes, so I still have these asymptotes at the same place as the normal tangent function, just the regular old plain tangent. But now, normally I would have some positive values to the right of the y-axis, but those positive values are going to become negative, right? So it's going to look like this over here, right? All those positive values became negative, and normally on the left side of the y-axis it's negative, but they're going to become positive because I'm changing the sign by multiplying by the -1 essentially. So essentially it flips it like this. Okay, so there's one cycle, and I can just repeat that cycle. Okay, so it sort of flips it around. All right, and let's go do one more. We'll have a 0 here. Okay, so it's going to look like that, and then we'll have another one here. All right, this video is going to get long because you gotta watch me. You gotta watch me draw these tangents. So okay, I'm gonna have another one here. Partial. We'll have a partial cycle here. All right, so there's a reflection across the theta axis, or the x-axis, the horizontal axis, I guess I could say. Now this other one is the tangent of negative theta. Now if you remember, we said that tangent is an odd function, so this is actually the same as the negative tangent of theta. So our graph is going to look exactly the same as the graph in part E. So there you go. I've gone ahead and drawn it in. But you can also see too, it's a reflection across the y-axis, right? All the positive x values essentially get flipped to the negative side, and the negative x values, or in this case theta values, get flipped to the positive side. So it's a reflection across the y-axis as well. So I could write that down: reflection across the y-axis. Okay, that's what the tangent of negative theta does, or tangent of any f of negative x does. It flips it across the y-axis. All right, so you can see a lot of nice symmetry going on with a tangent function. All right, well, that's probably enough for this video, and I will meet you for the next example.